Alright guys, so we've been looking at derivative applications. Today we're going to be looking specifically at kinematics. Now I'm going to go with this from the perspective that you have never done kinematics before. If you have, if you've been through physics, you may be able to skip this first part, or maybe it's just a good review for you. So go ahead, watch the video, skip up to the second half of the video if you need to, where we start working some problems. Totally up to you. Alright? So let's start here with displacement. Displacement is kind of like distance, right? Distance, you're measuring how far they've traveled. Displacement is just how far is it from where they started to their final point. Okay, so we're looking at the displacement, which is just a straight line from point A to point B. Regardless of whatever path they took, it could be a curved path, straight path, no, it doesn't matter. The displacement is a straight line between point A and point B, and how far is that distance. Okay, now a couple of things to recognize. Displacement is usually represented with an S. I honestly don't know why. I'm sure it has something to do with some Greek or Latin term that I don't know what it is, but it's represented by an S. It's just as well because D would be confusing because we already got derivatives and all that kind of stuff. So better that we got some other letter. The other thing is displacement is a vector. Now what that means is that the direction matters. Okay, so what direction you're going in is going to affect the displacement. So when you add displacements together, you can't just straight up add the numbers together unless they're going in the same direction, in which you can. If they're going in different directions, you have to take into consideration angles and stuff like that. A lot of times what we'll be looking at is straight up and down or left and right. Generally, right is going to be positive, left is going to be negative, up is positive, down is negative. And so if something's moving to the right, then it'll have a positive displacement over time. Okay, and we'll deal with some of that as we get into this. Next up, velocity. So what is velocity? Well, velocity is a change in displacement over time. Okay, one way of saying this is a change in displacement over a change in time. Now that should look somewhat familiar. How do you get average velocity? Well, you just take the final velocity, the initial velocity, and then you divide it by the total time. And that gives you an average velocity for the whole thing. That's assuming a constant acceleration. You can also take your total displacement, and divide by the total time. Okay, so I guess I should have just written that displacement. Okay, so if you ever need to find an average, then you just have to find out how far is it from point A to point B, that's the total displacement, and divide by how long it took him to get there. Okay, now instantaneous velocity should be easy given this right here. It's just d dt of s of t, the derivative of displacement with respect to time, and that'll give you the derivative. All right, which will be the instantaneous velocity. Let's go on to acceleration. Now, what exactly is acceleration? Well, acceleration is defined as a change in velocity. Okay, so being that velocity is a vector, then it could be a change in the magnitude of the velocity. It can also be a change in the direction of the velocity vector. Okay, so it actually doesn't have to change speed. So we cannot define acceleration as speeding up or slowing down, though often that's what it is. Speeding up would be acceleration. Slowing down is also acceleration, not deceleration. Deceleration is slowing down, but a negative acceleration is actually causing a decrease in the velocity. Now, if you have a positive velocity, then let's say that we have a velocity of 10, then as that decreases, then it could go to 9, to 8, to 7, and so on and so forth. So it's going down for a negative acceleration. But what if you had a negative velocity? What if your velocity was already down at negative 10? As it went down, it would go to negative 11, negative 12. So my velocity is decreasing as far as the numbers go, but that actually means that it's speeding up. It's just speeding up in a specific direction. Okay? It's going to the left, and it's speeding up in the leftward direction. Okay? Let's see, what else have we got about acceleration? How do you get average acceleration? Well, you take your velocity assuming that it's constant, you take your final velocity and you subtract your initial velocity and you divide by the amount of time. All right. Now to get instantaneous acceleration, you just do dv dt, the derivative velocity with respect to time, which is also d squared s over dt squared, right? So you could do the second derivative of the displacement, because the first derivative would be velocity, taking the derivative of that would then be the second derivative of displacement. Okay, now a couple of things to recognize. If it's to the right of the origin, you're going to have a positive displacement. To the left of the origin is a negative displacement. If it's moving to the right, that's a positive velocity. If it's moving to the left, that's a negative velocity. If the velocity is increasing, meaning you're adding to the velocity, then that's a positive acceleration, regardless of which direction it's going. If the velocity is becoming smaller, as in moving in the negative direction, and the direction of the negative of the number line, then in that case you have a negative acceleration. All right. Now here's an example. We're going to go ahead and talk through this one really quick. I may or may not write all the numbers and all the work down, but let's just kind of get an idea and talk about it. Okay, when a ball is thrown, its height above the ground is given by meters, where t is the time in seconds. From what distance above the ground was the ball released? Well, ball released means that time is 0. So we put in 0 for time, and we get 1.2 meters. Well, isn't that snazzy? All right, then it says find the derivative of s and state what it represents. Okay, I find the derivative, so the constant's going to go away. This is going to become, so s derivative of t, which is equal to 28.1 minus, and then 2 times 4.9 would be 9.8t. Now, of course, the first derivative of the displacement is the velocity. All right. So find t when s prime of t equals 0. So if we make that 0, then we're going to subtract the 28.1 and divide by negative 9.8. So for that, I'm going to need my fancy schmancy calculator here. So I'm going to take, so if I put 0 here, then negative 28.1, and then divide it by 9.8, negative 9.8, which will give me t equals 2.87. Which means that my velocity is 2.87 meters per second, so that it's moving to the right. Okay, so if you can picture this, if 0, the origin is here, I'm currently at time 0, I am 2.87, oh sorry, that is time equals 2.87, so it's not moving to the right. At 2.87 meters per second, I am stopped. Sorry about that. Okay, so from that point, we can then say, okay, at time 0, I was 1.2 meters to the right. So that was at time equals 0. And then after 2.87 seconds, I'm going to need to redo that. After 2.87 seconds, I am stopped. All right, what is the maximum height reached by the ball? Okay, the maximum height, remember, we can find the maximum height. Well, think about this. If the ball goes up and then comes back down, maximum height, you can get that a couple ways. One is to find the vertex of this equation right here, right? And then the maximum height would be the y value of your vertex. The derivative also gives you the change. And so we found when the derivative was 0, that was at 2.87 seconds. That means the derivative is 0. It's not changing right here at 2.87 seconds, which means if I take 2.87 and put it into the original equation, it should give me the height, the displacement, at 2.87 seconds. So that's actually what I'm going to do. I'm going to pull out my fancy calculator again, and I'm going to go 1.2 plus 28.1 times 2.87 minus 4.9 times 2.87 squared, and my final answer is 41.5. So 41.5 feet. All right? Now it's asking for the ball's speed when it's released. Okay, so that is at time 0, so I can get the speed by putting it in here, 0 for t, and I get 28.1 meters per second. At 2 seconds, so I put a 2 in there, so that'll be 28.1 minus 9.8 times 2. So 28.1 minus 9.8 times 2, and I get 8.5. And then at t equals 5 seconds, so same thing here, except this time I'm going to go 28.1 minus 9.8 times 5. And notice that this time I get a negative number, so negative 20.9. Now the question is asking for the speed. And because it's asking for the speed, I'm going to use 20.9. Okay, just like that. Now, it's 20.9, not negative 20.9, because speed is a scalar. The direction doesn't matter. And so the negative was just representing, because it's going up and down, the negative was just representing a downward motion. But at this point, the downward motion is not really important because it's just asking for the speed, so 20.9 meters per second. How long will it take for the ball to hit the ground? Well, if it takes, we can put a 0 in, obviously, and then you can solve using the quadratic formula. I'm not going to take time to do that. And what is the significance of the second derivative? Well, we've talked about that already. It's the acceleration. Okay, so there you go. We've got, and this in this case, acceleration is gravity. Right, gravity is the thing that's causing it to change. As the ball is flying through the air, nothing else, unless with minimal air friction, nothing else is really bothering it. So this is measuring the acceleration of gravity. Okay, so let's keep on going on. Let's play a little game. All right, and you're welcome to skip this part if you want, but this is very conceptual, dealing with kinematics. All right, so here's the game. We're going to assume that all motion in this game is in a straight line, either to the right or left. Okay, I'm going to give you some information, and I want you to answer with as much detail as possible. Tell me, where is the object in relation to the origin? Is it to the right? Is it to the left? Is it at the origin? Or do we not know anything about the position? Okay, what direction is the object traveling? Okay, is it traveling to the right? Is it traveling to the left? Is it stationary? Or do we not know? And last of all, is it speeding up or slowing down? Now note that I'm not asking is the acceleration positive or negative. I'm asking is it speeding up or slowing down. Slowing down is also acceleration, and it could be positive acceleration. Okay, so that's what I want you to look at. Or is this unknown? I guess you could add on a constant speed as well. Okay, so hopefully we'll see some of those in the next couple of examples. All right, so here we go. In this, it's telling me s of t equals 0. Where is the object? What direction is it traveling? Is it speeding up or slowing down? Now, for each slide, for the rest of for the next little bit, as long as we're doing this game, I would like for you to pause it right after I change the slide. You can kind of figure it out on your own, and then I'll explain the answers so that you know if you've gotten your answers correct. All right, so go ahead, pause. And here we go. Where is the object? Well, s of t, that's the displacement, is 0. So if s of t is 0, that's our position. So therefore, it is at the origin. Okay, and I may not write all these down, but I'm going to talk through them. What direction is it traveling? Well, that information is not given to us. Okay, so unknown. Is it speeding up or slowing down? Unknown. Again, we don't know those things because all it tells us is that s of t, the initial position, the displacement is 0, so it's at the origin. All right? Next question. Assuming that all motion is in a straight line, okay, this time it gives me s of t is positive and s prime of t is negative. So what does this mean? Well, this right here tells us that it is to the right of the origin. And this right here tells us that it has a negative velocity. So it's moving to the left. If I were to look at this on kind of a number line and say, here's my origin, I'm to the right of the origin, and I'm moving to the left. That gives me a negative velocity and a positive displacement. All right, next up, pause. Okay, this one, all it tells me is that the velocity right now is 0. The previous one's nothing about speeding up, slowing down. I don't have any of that information. This tells me that the velocity is 0. Okay, it doesn't tell me where it is, so I have no idea where I am. All I know is wherever I am, my velocity is 0. I'm not moving right or left. Okay, speeding up or slowing down, we don't know. It could be speeding up, and just at this instant, it's 0. Okay, next question. So here we got a little bit more information. We got a position, we've got velocity, we've got acceleration. If you haven't paused it, please do. Give it a try. So this time, what do I know? Well, I know my position. I know my position is at the origin. What direction is it traveling? Well, it says it's positive. That means I'm traveling to the right. And the acceleration is also positive. So if the acceleration is in the same direction as my velocity, it means it's going to become more and more positive, which means that I am speeding up. Okay, note that I'm speeding up not because of the positive acceleration, but because it's positive with a positive velocity. Okay, we'll look at a couple of situations where things maybe don't match exactly what you expect in just a moment. All right, so here we go. What have you got? Here's the origin. I know that I'm to the left of the origin. That's my position. My initial displacement is to the left. I got a negative displacement. It is moving to the left because the derivative is negative. Now the acceleration is negative. That does not mean slowing down. Negative acceleration means that my velocity is decreasing. So if I've got a negative velocity and it's going down more, that actually means that it's going to speed up. Okay, so what I've got is that I'm to the left of the origin, I'm moving to the left, and because the acceleration is in the same direction as the velocity, I'm actually speeding up. All right, so this time I've got a negative velocity. I don't know where I am, so I'm not going to draw a number line. I do know that I'm moving to the left, and I've got a positive acceleration. That means the acceleration is in this direction. So I've got a negative velocity, but it's increasing. So it's going from negative 10 to negative 9 to negative 8. My velocity is increasing in value. It's adding 1 every time, or 2, or whatever number it is, but it's adding every time. So what do you see happening there? It's not speeding up, is it? It's slowing down. Now these are all important ideas because we're going to get questions where it's not this crystal clear, and you're going to have to be able to interpret and put all that together to determine whether it's speeding up or slowing down. This is a much more common question than what is the acceleration? All right, because they want you to think about it and interpret and make some sense of it. All right, this one? I know that I'm to the right, and I know that I have a negative acceleration. I don't know if that's speeding up or slowing down because I'm not given any information about the velocity. If my velocity is to the left, then this is going to mean speeding up because I'm going to be going more and more to the left. If my velocity is to the right, then that means I'm going to be slowing down because it's going to be taking away from my velocity. But since I don't know that, then all I can say is it's unknown. It's unknown if I'm speeding up or slowing down because it's unknown which direction I'm going. All right? Okay. You know what? I think that's enough for this video. In the next video, I'll actually go through a couple more examples. Okay? But I just want to make sure before we got into examples that you were clear on the difference between displacement, velocity, acceleration, and their relationship to one another.